All right, so this video is to accompany number 11 that was on our Unit 7 practice test. And we didn't get a lot of time to solve rational equations, so that's why I'm recording this video. So there's two strategies to solving rational equations, and it depends on the type of equation that you have. Here in number 11, what we have is we have a rational equation that is comprised of a rational expression on the left-hand side of the equal sign and a rational expression on the right hand of equal sign. So basically we have two fractions set equal to one another. So in this case, what we are going to do, just like if you were multiplying or had two fractions set equal to each other, we call this a proportion, we are going to cross multiply between numerators and denominators. Some of you call this the butterfly. So that's what I've done here. So we've went ahead and I've cross multiplied. I took the quantity 2x plus 1 times the 5. It moved to the left hand side. I took the quantity x plus 2 and multiplied it to the 7, which ended up on the right hand side. And you can see that I've done that there. My next step is to distribute everything across the parentheses. So I'm distributing the 5 across the quantity 2x plus 1 and the 7 across the x plus 2. So that gives us 10x plus 5 is equal to 7x plus 14. After that, I'm going to go ahead and solve the equation. So I'm going to move stuff around. So here what I've done is I've moved the 7x over to the 10x by subtracting it, which leaves us with 3x. I've subtracted the 5 and moved it over to the 14, so 14 minus 5 gives us 9. And then finally, I go ahead and divide both sides by 3, and 9 divided by 3 is 3. So we end up with x equals 3. Now, something we always need to check for in our rational equations is we want to make sure we didn't end up with a value for x that would cause the whole entire one or more of the expressions to become undefined. And so the way I'm going to do that is I'm going to consider the value or values I got for x, and if I were to plug them into my denominators. So we came up with x equals 3. So what we're going to look at here is if I were to put 3 into x plus 2, I would get 3 plus 2, that's 5. That's fine. If I were to put 3 into the 2x plus 1, 2 times 3 would be 6, plus another one would be 7. I would end up with 7 divided by 7. And so in this case, I would end up with 7 divided by 7, which is 1. On the left, I would end up with 5 divided by 5, which is 1. 1 equals 1. X equals 3 checks out. Now, the other type of rational equation you can end up with is something like what we see in number 12. So in number 12, we do not have a simple proportion like we did in 11, because what happens is we've got more than one term on the left-hand side. There's a little bit extra to do here, but we will get back to the technique we used in number 11. So the first thing you need to do if you have multiple terms on the left-hand side or the right-hand side, or both, is you need to factor all of your denominators down to a prime factorization. So for instance, 15 would factor down to 3 times 5. 5x, while it really doesn't factor any further than that, I just wrote it as 5 times x to show that you do have two factors there. And then on the right-hand side, we just have x. When finding a least common denominator like this, what I'm going to do is I'm going to look at each of those prime factors, and I'm going to include it one time for each time it appears to its greatest power. So for instance, I look at all of my denominators. 3 only appears in one of them, and it's to the first power. So 3 goes into my LCD. 5 appears in both of these, but in both of them it's to the first power. So I just put 5 in one time and raise it to the first power. These two denominators both include an x, but I'm only going to put it in once, and I'm going to raise it to the first power because in both of them it was raised to the first power. Then I multiply that out. 3 times 5 times x gives us an LCD of 15x. Now, once we have the LCD for a rational equation like this, what I'm going to do is multiply both sides, the entire side, by my LCD divided by 1. And so I would also multiply the right side by 15x over 1. That's the LCD over 1. So you can see I've set that up right here in this next step. I've got my left-hand side of the equation. I'm multiplying it by the LCD over 1, the 15x over 1. And the right-hand side is being multiplied by 15x over 1. And the right-hand side of the equation was 1 over x. Once I've got that recorded, what I'm going to do now on the left-hand side is I'm going to distribute this 15x divided by 1 to both terms. And so you see that right here. I've applied the 15x over 1. I've multiplied it to the x over 15. I've multiplied the 15x over 1 times the x plus 5 over 5x. And then, like I had on the right side, I had 15x over 1 times 1 over x. Now, before we multiply, it's going to make your life easier if you go ahead and cancel common factors or cross out common factors. So for instance, in this first multiplication, I had a 15 in the numerator, a 15 in the denominator. I cancel those out or cross them out. In the second term, once I distributed, I had a 5x and I had a 15x. Well, 5 doesn't cross out the 15 completely, but 5 does divide into 15 3 times. So notice I've marked out the 15, I've marked out the 5, but I recorded a 3 there. And then I've also crossed out both of the x for x. And then on the right-hand side of the equation, I've done the same thing, x for x. Once we're finishing crossing out our common factors between our numerator and denominator in each multiplication, now we're going to go ahead and multiply. So in this first pair, I'm going to have x times x, so that's going to give us x squared. The second pair, I'm going to have 3 times the quantity x plus 5. And on the right-hand side, I'm just going to have 15 times 1. And so we get an equation that looks like this. X squared, because that was the x times x, plus the 3 times the quantity x plus 5, which is what came from the second pair, is equal to 15. I go ahead and distribute the 3 across the quantity x plus 5. That gives us the 3x plus 15. And I subtract the 15 from both sides, because since this is quadratic, I have to have it equal to 0. So I subtract the 15 from both sides and get an equation that reads x squared plus 3x plus 15 minus 15 equals 0. And so 15 minus 15, well, those are going to come out to be 0. And so really we're just left with the x squared plus 3x equals 0. Now, thankfully, that equation or that expression on the left will factor. It has a greatest common factor. Don't forget to look for greatest common factors when you go to factor. I can factor out an x. And that leaves us with x times the quantity x plus 3 is equal to 0. Once I've factored and it's equal to 0, I have something called the zero product property. And that means that the product of those two things can only be 0 if one of them is 0. So what we do is we take each factor and we're going to set it equal to 0, which is what I've done here. I have x equals 0, even though I've crossed it out, I'll explain why. And I have x plus 3 equals 0. So one of my possible solutions is x equals 0. I solve this one and I get another possible solution of x equals negative 3. Now remember, in the last problem I said we have to plug our solutions back in to see if they make it undefined or a false statement. Well, if I consider my solution x equals 0, when I come back to my original equation, both this second term and the right-hand side, if I allowed x to become 0, both of these would become undefined, which means that my entire equation becomes undefined. So I can't use x equals 0. It's what we would call a restricted value. We would have a vertical asymptote there for 1 over x. So we can't use x equals 0. So now I need to check my other possible solution, negative 3. So now I'm going to say, well, negative 3 over 15, well, that would be negative 1/5. I'll put negative 3 plus 5 would give me 2. Negative 3 times 5 would give me 2/15. I'm sorry, negative 2/15, because it would be a negative 15. And then here I would end up with a negative 1/3. So if I end up with negative 3/15 minus 2/15, that's going to be negative 5 over 15, which would be negative 1/3, which is what the right-hand side comes out to be. So I end up with a true statement, negative 1/3 is equal to negative 1/3, which means that the solution, x equals negative 3, is a valid solution. Now, this solution of x equals 0, so since we saw that it made the equation undefined, what we call that is an extraneous solution. And all that means is basically, if you look at the word extraneous, it's extra, and it comes from the solving process. So because we had a quadratic, we were bound to get two solutions. And so what happens is this solution does not work in it, so we say it's extraneous and we cross it out and only record the one that does work. That's it for solving rational equations for our test review.